Welcome back, future doctors. Today, we tackle NEET 2026 chemistry, focusing on high-difficulty concepts and tricky NCERT traps across physical, organic, and inorganic chemistry to sharpen your preparation. Let's start with physical chemistry. Question 1 focuses on the mole concept. How many moles are present in 22.4 liters of an ideal gas at STP? Is it A, 0.5 moles, B, 1 mole, C, 2 moles, or D, 22.4 moles? Review your basic molar volume constants. Remember Avogadro's hypothesis. At standard temperature and pressure, 1 mole of any ideal gas occupies a specific fixed volume regardless of its chemical identity. The correct answer is B. 1 mole equals 22.4 liters at STP. This is a foundational constant you must memorize for stoichiometry problems. Moving to chemical bonding. Question 2 asks, what is the molecular geometry of a methane molecule according to VSEP-R theory? Watch the bond angles closely. Hint, consider the 4 bond pairs and 0 lone pairs on the central carbon atom. How would they arrange to minimize repulsion? The answer is tetrahedral. In methane, the 4 electron pairs push apart into a 3-dimensional shape where each bond is as far from the others as possible. Next, thermodynamics. For an exothermic reaction, what is the sign of the enthalpy change? Delta H. This is a frequent point of confusion for students. Think about energy flow. If heat is released from the system into the surroundings, does the system's internal energy increase or decrease? The sign is negative, because the final energy is less than the initial energy. Delta H is always less than 0 for exothermic processes. Onto chemical equilibrium. What can we say about the rates of forward and backward reactions once a system reaches a state of dynamic equilibrium? At equilibrium, the concentration of reactants and products remains constant. But what is happening at the molecular level regarding the speed of the reactions? They are equal. Equilibrium doesn't mean the reaction stops. It means the rate of the forward reaction is exactly equal to the rate of the backward reaction. Organic chemistry time. What is the characteristic functional group found in all alcohols? Identify the specific atom combination. The functional group determines the physical and chemical properties of the molecule. For alcohols, it is the hydroxyl group, denoted as OH, in chemical kinetics. How does an increase in temperature generally affect the rate of a chemical reaction? Consider the collision theory. Higher temperature increases the kinetic energy of particles, leading to more frequent and more energetic collisions that exceed the activation energy barrier. Therefore, the rate increases. Almost all chemical reactions speed up when temperature rises, a key concept for both physical and organic chemistry. Let's look at electrochemistry. Define oxidation in terms of electron transfer. Does it involve the gain or loss of these subatomic particles? Remember the mnemonic oil rig. Oxidation is loss, reduction is gain. This simple phrase will save you from many errors in redox problems. Question 8. Describe the nucleophilic substitution reaction of methyl chloride with a hydroxide ion. What is the leaving group, and what is the nucleophile? The hydroxide ion acts as the nucleophile, attacking the carbon, while the chloride ion departs as the leaving group, resulting in methanol. Applying Le Chatelier's principle, if pressure is increased on a gaseous system at equilibrium, toward which side will the equilibrium shift? The system will try to counteract the change by shifting to the side with fewer moles of gas to reduce the pressure buildup. Finally, the NCERT trap, which noble gas is considered the most chemically inert and shows the least tendency to form compounds. While xenon and krypton form compounds under specific conditions, helium and neon are extremely stable. Neon is often cited as the most inert. Great job completing Part 9. Keep practicing these tough concepts. Join us next time for Part 10, where we reveal the top 100 most expected questions for NEET 2026. See you there.